Hello students, welcome to Decluttered. Today we will look at question 5 from JEE Advanced 2025 paper 1 math section. This is a very interesting problem on coordinate geometry and it can be solved in a few simple steps. So pause the video and give it a try on your own. Alright, let's get to solving this question. Usually I find that drawing a rough diagram is the best way to approach a coordinate geometry question. So let's do this. Given line L1 is the intersection of two given planes. Line L2 passes through the point 2, minus 1, 3 and is parallel to L1. So what we already have is, we have two planes. Let's say these two are the planes and there is some line L1 here. Alright, and we have a line L2 parallel to it. So just for convenience sake, I will draw it here, L2. And we know that it passes through the point 2, minus 1, 3, which I will denote by P here. Alright, let M denote the plane given by this equation. So let's draw another plane, and this plane is M. Now suppose L2 meets the plane M at point Q. So this is the line L2 and it meets the plane, let's say here, at point Q. Now R is the foot of perpendicular drawn from P to the plane M. So let's make a perpendicular to the plane and it intersects this plane at point R, let's say. Now we know Q and R are in the plane itself, so I have connected them as well. Now let's see what all information is needed to be found. We need the lengths of PQ and QR. We also need the area of triangle PQR and the acute angle between line segments PQ and PR. Alright, so let's get to finding these. Now we know that L1 and L2 are parallel to each other. That means it is enough to know the direction ratio of L1 to fully also describe line L2. Now one thing to keep in mind is that the direction ratios to the normal to any plane are given by the coefficients of x, y and z in the plane equation. So for example, let's take the plane P1 here and also P2. For the plane P1, the direction ratios to the normal, and I'll mark it as n1 cap, are given by 2, 3, 1 from this equation. Okay, and similarly for plane P2, the direction ratios for n2 cap are given by 1, 2 and 1. Alright. Now one interesting thing to note is that whenever we have the line of intersection of two planes, the direction ratio of that line is given by the cross product of these two direction ratios. This is because the line L1 lies in the plane of both P1 and P2 and hence it will be perpendicular to the normal vector of both the planes. Alright, so we can find direction ratio of L1 as equal to cross product of these two, which is 2, 3, 1 cross with 1, 2, 1. Alright, when you compute this, this comes out to be 1, minus 1, 1. Alright, now we know L1 is parallel to L2. That means this is also direction ratio of L2 and consequently the same for PQ. Right, because both points P and Q are on the line L2 itself. Alright, now let's look at the line PR. We can see that the line PR is perpendicular to the plane, as R is the foot of perpendicular from P to the plane. Therefore, the direction of PR will be the same as the normal to the plane. Again, we know the plane M is given by 2x plus y minus 2z equal to 6. Hence, direction ratio of PR will be equal to 2, 1 minus 2. Now we have the direction ratio for PQ, we have the direction ratio for PR. Therefore we can find this angle theta using the dot product rule, which is cos theta equal to mod of PQ dot PR divided by mod PQ mod PR, where these mod symbols here represent the magnitude of the direction ratio, and here the absolute value is taken so as to get an acute angle. So this will just be absolute value of 1 minus 1 1 dot product with 2 1 minus 2 divided by mod of 1 minus 1 1 and mod of 2 1 minus 2. This comes out to be 1 by 3 root 3. Hence this angle theta is equal to cos inverse of 1 by 3 root 3. But let's see option D. Here it's given acute angle between the line segments PQ and PR is cos inverse 1 by 2 root 3. Hence the option D is wrong. Next, let's get to trying to find any of these lengths. What I will do is find the length PR, as it is very easy to find because we have been given the point P and we know PR is perpendicular to the plane. We have the plane M given by 2x plus y minus 2z minus 6 equal to 0, and the point P is given as 2 minus 1 3. We know from distance formula of a point from a plane that D, which in this case is length of PR, will be equal to mod of AX naught plus BY naught plus CZ naught plus D whole divided by root of A square plus B square plus C square. Alright, so computing this, 2 into 2 plus 1 into minus 1 minus 2 into 3 minus 6 whole divided by root of 2 square plus 1 square plus minus 2 square. So this comes out to be 9 by 3, which is 3. Alright, so now we have the length of PR. So I will mark it here as 3. Now as can be seen, triangle PQR is a right angle at R. We know the length PR just now as 3 and we have computed this angle theta as cos inverse of 1 by 3 root 3. Therefore, using basic trigonometry, we can easily find the lengths PQ and QR. So first, let's compute PQ. So from this diagram, it can be seen that PR by PQ will be cos theta. So we have PR by PQ equal to cos theta, which would imply PQ is equal to PR by cos theta. And we know PR equal to 3 and cos theta is just 1 by 3 root 3, which implies PQ is equal to 9 root 3. Alright, and this is what the first option is. Hence option 1 is correct. Now for QR, from this figure, QR by PR is tan theta. Alright, so first let's write that down. QR by PR equal to tan theta. This would imply QR is equal to PR tan theta. We have to compute tan theta first. So let's take a triangle here for reference. We know that if this angle is theta, then this will be 1, this will be 3 root 3, because we had obtained that theta is cos inverse of 1 by 3 root 3. Alright, now computing this, we'll get this as equal to root of 26. Hence tan theta is equal to root 26. So substituting back here, we have PR as equal to 3 and tan theta is root 26. This will just become root of 26 into 9, which is equal to root of 234. So we have obtained QR is equal to 234 units. It's given as 15 in the option, so this option is also wrong. Now for area of triangle PQR, we have just now found the length QR and we know the length PR as well. And because this is a right triangle, the area of the triangle is just half into product of lengths of the legs of the triangle. So that means area of PQR will be equal to half into QR into PR. This comes out to be half into QR we just obtained root of 234 and PR we know is 3 units. So this comes out to be 3 by 2 root of 234 unit square. And as we can see, this is the option C. Hence, the answer to this question are option A and C. If you like the solution, don't forget to like, share and subscribe to the channel. Thank you.